Yeah, you cheated. Yeah, okay. All right, so our goal here is to get the equation from this graph, all right? And we know that it's not y equals x squared or f of x equals x squared. And the reason we know that is because the vertex is not the origin, all right? So the first thing that we do is to analyze this is we figure out where is the vertex of this thing. So show me where is the vertex of this thing. Go ahead and put it on the graph where you think it is, okay? All right, I got mine. What do you guys think the vertex is? -1, comma 1. You guys agree with that? Yep. -1, comma 1, okay? The -1 stands for the h of the vertex, and the 1 stands for the k. So the vertex is located at this point called h, comma k. And we need to write our general vertex form, okay? The general vertex form is f of x is equal to a times x minus h squared plus k. All right, this is called vertex form. How do you guys remember that from the last time, from the other lesson? Do you guys remember this? Vaguely remember this. This is an important part, and I found out yesterday there's a lot of holes in our understanding, so I want to make sure you understand the vertex form, because this is how you get back to what the equation is. Okay? Now, let's analyze a little bit deeper here. We know that the regular graph of y equals x squared has these points on it, so it looks like this, okay? And we go over 2, we go up to 4, and we go -2, we go up to 4. So we know it looks like that. That's the regular one. This is f of x equals x squared. Okay? And that tells me that the value of a is equal to 1. And the reason I know that is because I go right 1 and up 1, and that points on the graph. And I go left 1 and up 1, and that points on the graph. So if we analyze this red one here, okay, if I go right 1 and up 1, this points on the graph. Left 1 and up 1, that points on the graph. That tells me that a is a value of 1. That means that this graph has not been stretched vertically or compressed vertically at all. The value of a is equal to 1. All right, so now I know that this value is equal to 1. So f of x is now equal to x minus h squared plus k. If a was equal to 2, then I would go over 1 and up 2. That would tell me that a is equal to 2. But in this case, I know that it's not. All right, now since I know where the vertex is, I'm going to plug in to my equation. So f of x is going to be x minus, what's the value of h? -1, good. I'm going to square that. And then I'm going to say plus, what's the value of k? 1, very good. You guys follow so far? Can I move it up? Up this way? Or up this way? Okay, good. So f of x is equal to, if I clean up the inside, x plus 1 quantity squared plus 1. Now, I've noticed on the last 2 tests, people still don't know x plus a, how to square this. They think it's just x squared plus a squared. Super bad, no mistake. So let's remind ourselves, this is equal to x squared plus 2xa plus a squared. And if you don't believe me, you can use FOIL and you can multiply x plus a times x plus a, but you will get this. We're going to apply that right now. Since we have x plus 1 quantity squared, we're going to say f of x is equal to x squared plus 2x plus 1, and then plus 1 on the outside. So everything in the parentheses up here, all of this stuff, just became all of that stuff via that rule. Okay? Does that look familiar to you? Please do not forget that. That comes up over and over again throughout the year, and people are still saying that's just x squared plus 1 squared. Not true. So therefore, if we clean up, we get the equation f of x is now equal to x squared plus 2x plus 2. And if you take a look, that was the equation that I made to make this graph. X squared plus 2x plus 2. What do you guys think? Does that make sense? Yes, kind of? Kind of? All right, good. That's how we did that part. So you're going to be working on that in your group in just a second. The second and final thing I want to go over today is how to graph something like f of x is equal to 1/5. And talk about what this means, what this does. Okay? So comparing this to the regular old standard form, go away. F of x equals a x squared plus x plus c. Comparing, what's the value of a in this case? Yeah, a is equal to 1/5. What's the value of b in this case? 0. What's the value of c in this case? 0. Okay, good. So just comparing these two things, the only thing we're dealing with is a value of a. So multiplying by a fifth. So let's go ahead and do a little bit of analysis here. Make yourself a nice quadratic or a coordinate plane. Here's x, here's y. And let's put on the graph f of x equals x squared. Let's put that one on the graph first. So I know 0, 0 is on the graph. I know 1, 1 is on the graph. And I know 2, 4 is on the graph. And the reason I know those points are on the graph is because I'm just plugging them into my function here. So this is my red function. That's the one that I'm going to color in red. Then we're going to make another one, a blue function here, and it's going to be f of x equals 1/5 of x squared. Okay, so that 1/5, that value of a, 1/5, is that bigger than 1, or is that in between 0 and 1? What do you guys think? Okay, so that value of a is in between 0 and 1. If you have a value of a that's in between 0 and 1, what does that do to the graph? Does that make it skinnier, or does that make it like fatter and wider? Fatter and wider. Okay, it makes it fatter and wider. So we think that our blue graph is going to be outside the curve of our red graph here. And the way that we're going to take a look at this is we're going to make a table. So I'm going to use f, and I'm going to go f of x, and this is going to be my blue graph. If I plug in 0, what do I get out of my f of x function if I plug it into the blue one, the 1/5 x squared? What do I get? I get 0. So that point is still on the curve. All right, so 0, 0 is still there. Let's analyze if I plug in 1. What do I get out of this? 1/5. That's not very much, right? 1/5 is not very much. So if I go over 1, I'm up a fifth. That's basically right there. You guys agree with that? So that means that if my axis of symmetry, of course, goes down the center of my quadratic, it goes right through the vertex. So that means -1, 1/5 is also on the graph. You guys agree with that part? Okay. Let's put in another point. What's another point that we could see that would be good? You make 5. Now you guys are thinking. If I plug in 5, right? What's 5 squared? 25. What's 25 divided by 5? So what do I get on here? So 5, 5. Okay, so if I go over 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This point is on the graph. And likewise, the other point on the other side, because this is exactly 5 units from the axis of symmetry on the right-hand side. So I go 5 units in the other direction. 1, 2, 3, 4, 5. Put a dot there. And I'm going to have a graph that looks like this. So today they're going to ask you to stretch or compress these quadratics. And depending on the number you are multiplying by, your a value, if your value of a is bigger than 1, it's going to be a skinny stretch. If your value of a is between 0 and 1, it's going to be a wider stretch, okay? And I want to demonstrate that for you right here. So let's plug in, you don't have to write this part down, f of x, oh, I did it right, x is to a x squared. Okay, and I'm going to make a graph of this, and we're going to look at it. Right? Make that a little bit bigger. And I'm going to give a an arbitrary value of 1 in this case. And we're going to make a slider for it so we can take a look at it. And let's move this over here. Okay, so if I make a bigger than 1, what's the graph going to do? Yeah. If you really go to the library, no. If I go a bigger than 1, okay, notice what's happening to my graph. It's getting skinnier, right? Now, if my a is in between 0 and 1, and we'll make this a little bit wider so we can see it. So in between a 0 and a 1. So let's go in between 0 and 1. Notice that it happens that my graph gets, look, wider than this, correct? You guys? Now, what happens if I go less? What happens if I go 0? What do I get? Well, I get a line if I go 0, right? But if I go negative, what happens to my graph? Yeah, it goes downward, right? Oh, so let's take it off discrete value. And let's go down, and it's going to open downward, right? Exactly. Because if the value of a is negative, then it's going to open downward. So today you're going to be practicing values that are in between 0 and 1. It's going to be wider. If you go larger than 1, you're going to get skinnier. Is that making sense? All right. Any last questions or thoughts before we practice together in class? Sweet.